Alright, so this is the second review test that we took on Friday. I know that some of you weren't able to finish it in time, so hopefully you're checking this out to make sure you understand some of the problems that you didn't get to see during class. So, our first question, we're looking at a couple solving problems. The first one is a quadratic equation. It's in standard form, so you want to kind of make a note of that. You have quadratic, it's in standard. The easiest way to solve this would be to try to factor it. Another option would be to put it into vertex form. A third option would be the quadratic formula, but factoring is usually the fastest. So here, if we're looking for numbers that multiply to 40 and add to -6, what works out is -10, +4, which means we have solutions of 10 and -4, things that make each of these factors 0. The second question, this is not something by hand. This is a calculator question. So what we're going to do is we're going to look at the graph of these two equations. The first equation that we can try here, we take out our calculator, we can plug in your y equals menu, which is right there, an equation. We're going to plug in 3 raised to the, using the little caret button, x. If your calculator looks like mine and it actually makes it go up to the exponent, you have to press to the side. If yours actually types a caret, you can just keep going on. -4. That's our first equation. Our second equation, we want y equals, and our equation right now is not y equals, so we have to go back and change it. I'm going to subtract 9x, get -2y equals 8 minus 9x. Divide everything by -2. We get y equals -4 plus 4.5x. Now that is something I can plug in the calculator. We had -4 plus 4.5x. We hit graph, and we'll see the picture. This is our first equation, the one with the exponent, and our second equation, which should be a line. You can see that they cross 2 times. That means we're going to get 2 different answers. To find out where 2 lines intersect, we want to get to this calculate menu here, which is above trace. So we hit second, trace. I want to find out where things cross, so I hit intersect. First curve, move the cursor left or right until it's about where they cross. Hit enter, enter, enter. We get 0.314 and -2.58. We weren't told what to round to, so I'm just going to show a couple of decimal points. I've got my graph for the exponential, and my line looks something like that. The point here where they cross was 0.314 and -2.886. Same thing for the second point. Second, calc, go down to intersect, enter, move the cursor until it's where they cross again, enter, 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 and this point is at 2, 5. Those are the points where the lines cross. Those are our solutions, and that is our answer. Third question, we have a square root. I want to get rid of the square root, so I square both sides. When you square square root, they cancel. You do not need the absolute value on these when you're looking at when you square it. If you took the square root, you would put absolute value, but we squared it. Here, you do not want to write x squared minus 16. That is not your entire answer. You don't just square each part. Remember, x minus 4 squared is x minus 4 times x minus 4. We distribute. There's also a minus 8x, and -4 times -4 is plus 16. This is a quadratic like question 1, so I'm going to subtract x. I get -9x. I'm going to subtract 2. I get minus 14, plus 14, excuse me, and x squared, leaving us 0 on the other side. This will factor. We have -7 minus 2. 2 times 7 is 14. -7 minus 2 is -9. We get answers of 7, 2. And we want to check our answers. You should always do this, and especially in a problem that's a square root. I want to check what happens when x is equal to 7. I plug in 7 for x. I get that the square root of 9 is 3. That's true. When x equals 2, plug in for x. I get that the square root of 4 is -2. That's false. That is not a solution. We call it an extraneous solution. Question 4 is an absolute value question. I'm looking to solve. First, I'd like to get my absolute value alone. So we can subtract 4, divide by 3, And now the absolute value is alone. Once it's alone, we can make two equations. Whatever is inside of the absolute value could be equal to 4, or whatever is inside of the absolute value could be equal to the opposite of 4. Add 2, you get that x is 6. Add 2, or x could be equal to -2. Question 5, we're looking to graph a system of linear inequalities. They are inequalities because we are looking at less than or greater than, not equal. That would be an equation. But we want to treat it like it was an equal sign. We're looking at a line, and it has a y-intercept of 2 and a slope of 1/4, up 1 over 4, up 1 over 4. You can go backwards, down 1, down 4, down 1, down 4, and we can connect them with a line. And I'd like to know where to shade on this line. First off, we're looking at less than or equal to, so we want to use a solid line, so I'm not going to change our line, solid line, but I want to know where to shade. So I'm going to test a point. I'm going to test 0, 0. I'm going to plug in 0 for y, plug in 0 for x. I get that 0 is less than or equal to 2. That's true. So here's 0, 0. That's below the line, and I shade it in. Our second line, to graph it, a couple options. The first option is I'm going to make this so that it is y equals. So subtract the 6x. You get 2y is greater than 8 minus 6x. Divide everything by 2. 2 divided by 2, we get just y. 8 divided by 2 is 4. Negative 6 divided by 2 is minus 3x. So we have a y-intercept of 4, a slope of -3, down 1 over 3, down 1 over 3. It's a negative slope, so the line should be going downward, and that is what is happening in our graph. Left to right, it moves down. This time when I draw on my line, I just have greater than. There's no equal to, so I'm going to connect it with a dotted line. And I'm going to test 0, 0 again. I have plugging into the original equation, 6 times 0 is 0, plus 2 times 0 is 0, is greater than 8. Is 0 plus 0 greater than 8? I don't think so. 0 is definitely not bigger than 8. That's false. So when I plugged in 0, 0, the point did not work. Since the point did not work, I want to shade the other side of the line, which is right there. The solution is the graph. So the overlap region, which we can show with the highlighter, is the solution. You do not need to do any more work. That is your work. The second question, is 3, -2 a solution? Well, 3, -2, that's right 3, down 2. What I want to know, is that in this overlapping solution? And is that in the overlapping region? The answer is yes. It is in the shaded region of both inequalities. And that's our question here. Graph a line, test a point, shade it in. Graph a line, test the point, shade it in. If it works, shade with the point. If it doesn't work, shade opposite the point. Question 6, we're told that a ball is being kicked. It goes up, it's going to come back down. We're given an equation to model how high it is at a given time. And what I'm going to do is I'm going to take that equation and plug it into the calculator. So we go back to our calculator, clear out the information we had from the first question. And our equation was -16t, we're going to use x in our calculator, squared, plus 40x. I'm going to hit graph. This window is not going to be particularly helpful, so I'm going to change it. It looks like my x value, I don't need as much space. Let's try from -1 to 5. My y value has to go up a little bit higher. I couldn't see the top of the graph. Let's try 30. Let's see what our graph looks like. That seems to include all the important information. The beginning, where it hits the ground again, and a highest point. A asks, when does the ball reach its highest point? Well, our graph looks something like this. I want to know, when is this highest point? So what I'm looking for is, what is that x coordinate? In our calculators, we can find this by looking in that same menu for the intersect, but this time instead of picking intersect, I'm going to pick maximum, because it's the highest point. It's going to ask you for left bound and right bound, Move the cursor to the left of the highest point, hit enter. Move it back to the right of the highest point, hit enter, and put it in the middle, hit enter. We can see that the highest point happens at an x value or t value of 1.25 seconds after the ball is kicked. What is the highest the ball goes? Well, we can see that the highest point is when y is 25, which is 25 feet. I want to know when the ball lands at the ground. Well, if it starts on the ground, it lands on the ground here. I want to know what is that point. So I can go into my menu. This time I'm going to pick 0, which is another name for the x-intercept. Move the cursor until it's close, but to the left of. So here's our point, to the left of it, to the right of it, in the middle. And I get that it lands the ground at a time of 2.5 seconds, 0 feet in the air because it's on the ground. And then the last question, there's a couple ways we could do this. I want to know when is the equation equal to 10. You could try to solve that by hand and use the quadratic formula. What we're going to do this time is, since we have our calculators out already, I want to know when do I have a y value of 10. So I enter 10 as a second equation. I hit graph, and you can see that it has a y value of 10 2 times. I'd like to find out where those cross. So second, trace. I want to find out where they intersect. First curve, hit enter, enter, enter. I get that it crosses when t is equal to 2.22. And again, I can go across the line to the other intersection point. I get second trace, intersect, and it looks like I did all that work for nothing. That's all right. Go back across the line again. Enter, enter, enter. And we can see that it happens also when t is 0.28 seconds. So what does that mean? It means the ball has a height of 10 feet at 0.28 seconds after being kicked, when it's going up, and 2.22 seconds as the ball descends back down. And that is the end of the first half of our test.